Good day, madam. My name is Chinyanin, normal matrix 281924. Now I will present our group assignment 4. Our problem is James is a financial management manager in public bank. He has 15 jobs to do in 6 hours. When a job is completed by James, he will receive a profit paid by the customer. Now this is our random solution data. This data is created by the Excel VBA. And now we need to do the debouches. First, we need to set a parameter setting. The double turner is 3. Neighbor, we need to create 3. Interactions is 4. Local search, we need to flip 3 jobs. Initial solution, we choose the jobs 6, 7, 8, 9, 11, 12, 13, 14 and 15. So in first interactions, we need to create 3 neighbors. So the first neighbor, we need to flip the job 1, 2, 3. So after flip, this is our new neighbor. So we need to calculate is feasible or not. So this neighbor, first neighbor is feasible. So the total profit is 3,900. For second neighbor, we flip 7, 8, 9, the job. So this will be our new neighbor, and the profit is 1,950. And third neighbor, we flip the 13, 14, and 15. So the total profit is 2,050. So compare these 3 neighbors, we choose the highest one, which is neighbor 1. The first neighbor is 3,900. So this will be our x1. So in second iteration, we need to use this neighbor, this x, to flip the job. So because the first iteration we flip the job 1, 2, 3. So in second iteration we cannot use it again. So we choose 4, 5, and 6 to flip. So the second iterations, the first neighbor, our profit is 3,950, and second neighbors we flip 7, 8, 9, and the profit is 2,900. And we do again 3 neighbors. The third neighbors we flip 13, 14, and 50. The profit is 3,450. So we compare again these three neighbor and choose the highest one. So this will be our x2, and we use this x to do in the third iterations. So we do again until we repeat the step until the fourth iterations. So after that we do the iterations. Next we need to propose our best solutions. So we list the x that we choose in previous step. So our best solutions is x4, since it has the highest profit, which is 4,050. For genetic algorithm, first we need to set the parameter setting. We set the generations is 3. The population size equal to 8. So it means we need to create 8 chromosomes. So crossover probability is 60%. So type of crossover is 1 point. Mutation probability is 30%. And this is our random number, set of random number. So first we need to generate 8 chromosomes randomly. And second, we need to calculate the percentage, cumulative, and range of random number. So next step, we need to calculate how many parents we need to be select. So the formula is crossover probability times the number of chromosomes. Crossover probability is we set is 60%. So we times the 8 chromosome. So the total parents we need to select is 5. So we see the random number. Our first random number is 7. So the random number 7 is at the range P1. And second random number is 19. So it's at P2. So the random number 13 is P3. And because the parents we select is need even number, so we choose 6 random number here to do the crossover process. The crossover process, we set the type is 1 point, so we just randomly choose a point here to separate. So for this column, we maintain the same. We just write here, maintain the same. And this column, we will change. How to change is this will move to the down here, and this will move up in here. So this also same, because over here this will move down, and this also will move up here. So after that we will do the mutation process. Because this we will choose 5 parents, so in mutation process we also need to choose 5 child here randomly. So we need to calculate how many cells we need to mutate in this mutation process. So the formula is mutation probability times number of cells in the chromosome. So it's 40% times the 50, so equal to 6 cells. So we need to choose 6 jobs randomly to flip become a new child. After that, we will generate the second generations here. So because we need a new generation, we need to have 6 chromosomes. So because we need to calculate this all child is feasible or not feasible. So if it is feasible, so we can write here the for new chromosome. So because we just have 5 chromosomes here, another 3 we need to select from the previous chromosome. We need to choose the highest 3, which is 3000 P7, P4, and P2. So here we need to choose these 3 to fulfill 8 chromosome here. So in second generation, we also do the same step. We move to step 2 and do the same step until we do the third generations. So in third generations, we can move to step 6, which is propose best solutions. So since this problem is maximum problem, so the best solutions is the profit with 3,950, which is P2.
Good morning, madam. My name is Lee Kaijo and my matrix number is 281756. Now, I would like to continue with the simulated annealing. So, we set the parameter settings as follows. Temperature level is equal to 3. Number of neighbor at each temperature is NT equal to 3 and let T equal to 2. So, reduction of temperature is Ti plus 1 equal to 0.6 Ti. So, initial temperature is 80. Set of random number is 12, 21, 30, 35, 49, 56, 70, 65, 28, 17, 90, and 83. So in each local search, we flip 2 jobs. So these are the initial solutions. So steps 1, we will generate the neighbors. So we're using the initial solution and the temperature level 1. So we will flip in each neighbor. So we are going to do in 3 neighbors. And neighbor 1, we flip job 3 and job 7. Neighbor 2, we flip job 5 and job 12. Neighbor 3, we flip job 1 and 8. So after that, we will do the reduction of temperature. So we are going to generate neighbors at level 2. So we are using the same ways, same with the step 1. So until we do until the level 3. So step 4, we propose the best solution, which is we compare x1 until x9 to compare the best solution. So since this is the maximum problem, so the solution to maximize the profit is z equal to 3,650. So the solution which is x9 equal to this solution and zx9 equal to 3,650.
So for greedy solutions, this data is come from the assignment 2 data, solutions by constraints. So for double chance, we also same step as the random solutions one. So double ternary is set 3, neighbor 3, iteration is 4. Local search, we need to flip 3 jobs. Initial solutions, we select the jobs 3, 4, 5, 6, 7, 11, 12, 13, and 50. So the first interaction, we create 3 neighbors. So first we flip 1, 2, and 3. So the total profit is 3,850. And second neighbor, we flip job 7, 8, and 9. The total profit is 4,000. The third neighbor, we flip the job 13, 14, and 15. So the total profit is 3,850. So comparing these 3 neighbors, the highest is 4,000. So this neighbor will be our x1. So this will we will use this to do the second iterations. So first neighbor we also flip 4, 5, and 6. So the total profit is 2,750. So we also do the same step until the iterations 4. So next we can compare the solutions. So by comparing the x1, x2 until x5, the highest one is our x2, which is 4,000. So because it is a maximum problem, so this is our best solutions with the profit 4,000.
Next, we are going to using simulated annealing to do in the greedy solution. So we are using the same parameter settings as the random solutions. So the temperature levels is equal to 3, number of neighbors at each temperature is n t equal to 3, let t equal to 2. So reduction of temperature is Ti plus 1 equal to 0.6 Ti. So initial temperature is 80, set of random number is 12, 21, 30, 35, 49, 56, 70, 65, 28, 17, and 90, and 83. So we will flip 3 jobs. Okay, in this initial solution, this is the initial solution. So first step, we're also using the same way, which is generates neighbors. So we have the 3 neighbors and we flip the jobs in, flip 3 jobs in each neighbor. So now here are the flipping. So after doing the step 1, which is generate neighbors at level 1, so we will do the reduction of temperature. So we continue with the step 2. We are using the same way, which is in step 1. So still the same, we calculate the reduction of temperature for step 3, which is generate neighbor at level 3. So after doing the same ways at level 3, we propose the best solutions. So we compare x1 until x9 to compare the best solution. So since this is the maximum problem, so the best solution to maximize the profit is z equal to 4,100, which is x8 with this solution and zx8 equal to 4,100. Next, we are going to compare the between random solution. So by using the meta heuristic, which is tabu search, genetic algorithm, and simulated annealing to solve this problem, we have find out that each meta heuristic has different ways to solve it. So for the best solution in tabu search is 4,050, and simulated annealing is 3,650, while for genetic algorithm, the best solution is 3,950. So by comparing these 3 meta heuristics, we have found out that tabu search is the best ways to use in the random solution to maximize the profit with 4,050. Next are compare between the greedy solution. So for greedy solution, we only use the tabu search and simulated annealing to solve the problem. So in tabu search, we found out that 4,000 is the total profit and simulated annealing is 4,100. Since this is the maximum problem, so by comparing these 2 methods, simulated annealing is the best ways to use to solve this problem because it has the best higher profit, which is 4,100. Okay, now I would like to conclude the project. So in conclusion, this experimental result shows that the proposed meta heuristic algorithm are efficient for providing a good result. So in this paper, we applied genetic algorithm, tabu search, and simulated annealing as the meta heuristic algorithms for solve this problem. And they have their own efficient ways to solve the problems. So the result shows that GA, TS, and SA algorithm have effectively demonstrate the ability to solve this optimization problem. So the computational results shows that the tabu search algorithm has the better solution quality than other meta heuristic algorithm for solving the random solutions. Besides, simulated annealing algorithm shows it has a higher profit than other meta heuristic algorithm for solving the greedy solutions. So as the future research, a hyper heuristics can be developed to choose a more effective meta heuristic automatically according to the implemented problems. Thank you. That's all from me and my group members.